So I want to invite Jeff Houston up to talk to us about IPv6, DNS, and Big Packets. Thanks.
Thank you and good morning all. I work for APNIC, the numbers registry in the Asia Pacific area, but as chief scientist I get to play. And one of the ways I play is actually to look at how good a job you guys do and how well you're doing with that. And of course, as we all know, because we've been talking about it for, about 30 years, there's this thing called V6, right? You meant to say yes, yes, we all understand. Yeah, thank you, right? And there's this other thing too, it's called the name system, otherwise known as the DNS, and without it, you'd be still banging the rocks together trying to figure out how to coordinate hosts.txt. So, when you put the two things together, you get some really interesting collisions about what's going on out there. So today I actually want to talk about this topic of IPv6, big packets, and the DNS. So just to tell you, this is not a new conversation. We've been working on this stuff for, about 30 years, trying to make it work, trying to make it better. And, hopefully all of you know about this, and it's absolutely nothing new. Yawn, I don't need to go through that stuff anymore. And we're really good at this. We are obsessive compulsives. When I worked in the telephone company in Australia, I was told that back in 1987, they started their year 2000 date rollover committee because, you got to be prepared. So we thought this transition stuff was going to be a walk in the park. It was just going to happen. That we all would appreciate the fact that you were running out of V4 addresses. And we were never, ever, ever, I promise, going to get to the last one. You guys would have picked up the clue that we're running out and would have deployed V6. Obviously, either we didn't shout it out loud enough or you weren't listening. Because this is not the plan you're running. We started crunching down the bottom of the barrel in 2011. That's 6, 6, that's right, 6 years ago, and you're still saying, haven't got a problem, V4 is just fine. So, I don't know how you're doing with your NATs, but they're working hard. So the plan is not what you're doing. There is a different plan, but let me understand this a little more. Originally you said, well, V6 is kind of, the zombioid cousin out the back. And if you're running V6, you've got to do it across overlays because we just don't want to know about you. It's your problem to connect up the dots together. And so we had 6 to 4, we had Teredo. And then we realized when we looked at the numbers that the only reason why you ran Teredo or 6 to 4 is that you hated your life. Because the failure rate was about 20%. It added not just a few seconds of RTT time to your sessions, but a few minutes. This stuff was just pathetically bad. So, first message, if you think tunnels are good, there's something wrong with you and your customers. And that relates to MPLS just as much as it relates to anything else, but I digress. No one reacted. That was a big one. MPLS is great, believe me, not. Then we're in this kind of dual stack area. And funnily enough, you can get these days V6 packets across most of the internet without tunneling, thank God. Most of the transit providers do a decent job in dual stack. So what we've got is kind of transit running V4 and V6, and then kind of the edge networks is sort of a bit here and a bit there. And this is kind of the phase 2 idea, that the IPv6 networks no longer needed these zombioid tunnels, thank God, and now they're meant to run kind of normal stuff across normal transit. And the theory goes that somewhere, and we used to say next year, and then we got bored with that, and then we said in 5 years' time, and now we've all dropped out of the prediction business. I have no idea how big and wonderful you will make your NATs, but at some point, in theory, gravity will take over, you'll look down and find there's nothing there, and you'll figure out you really, really need to run V6. But a few of you will still be in denial because, you're good at that, and you'll have these edge networks which will have to tunnel V4 over V6, and we will finally get our own back on you. So this is the idea that the mythical sort of endpoint is going to look a lot like that. Where are we now? We're into phase 2. So 15 to 20% of the world have V6 capability as end users. And most new deployments, they tend to use V6. I think you'd be mad not to. You need some kind of future insurance. And of course, v4 always works, so you just NAT like crazy. And gradually the v4 networks that are legacy are being migrated over. But you know, yesterday you had a lesson in economics, and I hope you were listening. 2 lessons from that. When you've reached the bottom of the barrel, call for government regulation. I heard that too. The other thing is that if it's not a problem, you won't fix it. And so there's no problem with a v4 legacy network today, so you're not going to fix it. And that's the reason why, although the mobile folk are really at the sort of the bleeding edge of this problem, the wired network, largely put out, largely saturated, largely static, is not changing, because if you change to dual stack, you're not going to make any more money. It's cost without revenue. So, you know, the migration is really, really slow. Where's it happening? I'd never have guessed this, would you? I'm like Belgium. Had no government for 10 years, you know, political mess. But Belgium, absolutely out there. America, okay, fine, someone got the message. India? I'm like, my God, they're one of the biggest areas of v6 population on the planet. My hat's off to them, it's brilliant, but I never ever would have thought India, Greece, Belgium, Germany, and the US would be in this bucket of folk who are leading the charge. Never ceases to amaze me. How far have we? As I said, 14 to 15%, you know, this is cool. So the current situation is that, like it or not, and whether you sort of think it's good or not, the glue of the internet is v4. v6 is still kind of a little bit of optional extra, a few trinkets on the side, unfortunately, but that's just the way it is. And we're right in this middle of the transition. The theory goes, and it's a great theory, that your applications prefer to use v6. So if I deliver you both protocols, if you've got a choice, the server supports v6 and v4, you support v6 and v4, you will prefer to use v6. This worked fine when the gap was 300 milliseconds. But Apple always likes skating over the edge. Not close, over. So the current draft from Apple says, no, that's too slow. Let's make the time difference 50 milliseconds. Is your v4 and your v6 routing systems entirely congruent? Do they travel the same paths between the same 2 endpoints? Hell, why should I be asking you? I know they don't. And now the tolerance, if Apple get their way, is not 1/3 of a second, which is pretty slack. v6 will mostly be preferred. If you get down to 50 milliseconds, all of a sudden you better look at the health of your CGN, because it's going to be under a lot more stress. What apps do and what you guys do are intricately tied together. Don't lose the plot, don't lose attention here, because this matters. The other thing is the stats I gave you are misleading. I'm a client, you're a client, it just doesn't matter about our v6 uptake, it's the servers that matter. The server migration number is everything, because that's what determines what clients do. So in this client-server world, don't look at the general broad data, that's not really that important. Look at where your traffic goes and how much of that could possibly be on v6. So it's server migration, cloud migration. Who's the most conservative folk on the planet with respect to IT? Well, it's the business and enterprise world. Oops. So you either need to put the pressure on them or tell them that NATs are really, really good and are going to last forever, because, you know, there's a problem. Anyway, the problem is that no one can really deploy v6 only. And you've never really put it to the test. And that's an issue, because we're really not sure it can work. And when I hear these folks saying, we're running a v6 only network, I sort of scratch my head and go, really? I'm like, there's no v4 at all? None? Because I really wonder about that. Could you operate a network that was entirely v6, no v4 at all? Because if the answer is yes, I'll sit down and shut up. You know, I'll just go away and go, life is wonderful. But I suspect, you know, there is an issue here. So let's actually understand what's going on and why. Here's a packet header in v4 and a packet header in v6. 2 things changed, and they were fundamental. All of those options and padding fields that we don't use in v4 got replaced by extension headers that we don't use in 6. Yawn. However, the fragmentation field got pushed out as well into an extension header. That's a big thing. That's not just a little thing. Why did we like the internet as distinct from DECnet, AppleTalk, or anything else? What was the blinding bit of inspiration behind that packet design that no one else had a clue to think about. What was the thing that made it work? What made it work was fragmentation. As an overlay network, a network of networks, when the packet you had was too big to squeeze in that X25 piece of shit, sorry, that piece of crud, whatever it was horrible. If it was too big, the router just simply said, no problem, I will just shred this packet down to the right size and send the fragments onwards. I won't tell that end because they don't care, I'll just adapt. And that adaptation was actually the golden piece of inspiration that made this technology so much better than DECnet, sorry, digital HP, whatever you call yourselves today. So what have we done in V6? Well, we changed it. And we changed it in ways that I think only now we're truly appreciating the awesome, I hesitate to use the word beauty, there's another word. So let's have a look at V4. You found us a path that was too big. You just shredded it and sent on the other bits. Nothing went backwards, traffic is always flowing forward, routing is going forward, the internet works, we're all happy. V6, oh my God, it looks like a 3G network diagram, doesn't it? Oh shit. So I reach the router that says the packet's too big. Will it shred it? No. No, I'm not allowed to fragment packets. I have to send you back an ICMP. This ICMP contains the packet header that says, that packet's too big, bleat. Here's the packet size you should have been using. Oh source, try again. And the source is meant to say, I recognize that I sent this packet, I will send back fragments. Now, you shouldn't believe that story, because there's a bunch of parts about that story that are really, really weird. Inside an MPLS unidirectional tunnel, one way forward, what do you do with an ICMP message that's meant to go backwards? Pray or send it forwards? But you've got to do something, and you cannot send it backwards. Oops. So this whole idea that the middle can reach backwards is really good 1980s thinking. It's tolerable 1990s thinking. It doesn't work today the way we thought it should work. Oops. And what about ICMP itself? You know, what do you do with ICMP packets in V4 networks? Does anyone actually look at them? Put your hand up. There's only one of you. Because everyone else reckons they're unauthenticated noise from the middle that's used in DDoS attacks, and they're right. Because I don't know if the middle of the network's the middle of the network that I sent a packet to, or some other invented fiction. Because in this day and age, the network is untrustable. You really, really shouldn't trust it. So when I say to you, don't drop ICMP packets with fragmentation, packet too big signals, you kind of go, I just heard you say I shouldn't drop ICMP. Didn't hear the rest of the message, and frankly, I drop it because it's evil. My security folks say, die, die, die. So, this is a problem. So, I'm the sending host. I get this ICMP message back. What am I meant to do with it? Well, if I'm TCP, I've got all those unacknowledged packets. And if I'm really clever, I look inside the ICMP message, find the TCP process control block, communicate a message up to that TCP session saying, you just lost it, consider this a NAC, a negative acknowledgement, resend the packet gratuitously by changing your MSS. Don't worry, just look at the code. For UDP, panic. I never remembered the packet, it's UDP. I've got this message saying this event I've forgotten didn't work. Hang on a second, I've forgotten that event. You're telling me it didn't work, I have no idea what to do. I've forgotten the packet. So there's sort of an I should do something. I have no idea what. I could store it in a forwarding cache. And you, nice person that you are, send me 1 billion of these V6 packet too big messages for different destinations, and because I'm UDP, I have no idea whether I communicated with them or not. My cache disappears. Thump. So this is a denial of service attack. I've really got a problem with how to handle it. But it's okay, because we've invented a new technology which is even worse. It's called Anycast. Content folk, listen up. If you think V6 and Anycast works, consider this again and weep, because it doesn't. Because paths in the network are asymmetric. Remember MPLS, there is no backwards. There is only a bunch of forwards. Now on the forwarding path, we all agree what the anycast instance is. On the backward path, we have no agreement at all. That ICMP message is not necessarily going to go back to the person who sent that packet that was too big. It could go to any part of your ICMP cloud, your anycast cloud. Well, that doesn't work, does it? And now comes the next bit, which is truly horrendous. I notice these days, if I want to do 100 gig, I actually do 4 by 25 gig, right? Because there is no 100 gig serial. How do I load those 4 25 gig paths? I look inside the packet and find the flow, and I try and put packets on the same flow on the same path, because out-of-order packets for TCP is the nightmare from hell. Yes, yes. In v4, I know where that transport protocol is. At offset number 44, blah, 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 and off we go, fixed point. Where is it in v6? Because I've got this fragmentation header that kind of makes things different, and I don't know how long that chain is, and I've only got, about 2 or 3 nanoseconds to go and figure out what flow it is, and I'm going to drop the packet. I'm going to drop the packet. And a lot of transport-sensitive equipment drops fragmented packets in v6. Now, we measured it one way. Fernando Gont, Jen Linkova, Andrew Sullivan put out RFC 7872 and sent fragmented packets into the big servers and said the drop rate's horrendous. But no one really paid attention, because you don't send big requests, you get big answers. So we thought about this and thought, well, why don't we test the reverse? Why don't we push big answers back to clients? So, there's this ad system out there. It's really cool. You should watch more ads. Why? Because I put out ads, and in those ads there's a lot of scripting. And the script is really easy. Get this URL. But I fiddle with both the DNS and the URL itself. A lot of work. So the query comes to me. Why? Because it's unique. I have this DNS server, but I fragment the answer. I don't care how big it is, I just fragment it. Will your resolver get the answer in 6? And also with the web server, I put it through the same fragmenter, because I can. How do I test this? Well, if you're really, really quite cunning, you can do this in the DNS. Because if I send you a delegation and I don't send you the glue records, you've got a problem as your resolver. You have to figure out exactly where that delegation went, and only then can you resume your normal resolution. So I send you back a fragmented answer for the name server, and I can see if you got it or not. And I know it's you and not some other resolver. I've got you pinned down and cornered. There is no escape. For the web server, it's easy. If you acknowledge the fragmented TCP packets, you've received it. If you don't acknowledge them, you're dead. So let's have a look at this a little bit. Wow. Almost 4 out of 10 of everyone who uses a v6 capable DNS resolver can't receive big answers. And if you use Google's public DNS, that includes you too. Half of the world is included in that number, because half of the world uses v6 capable DNS resolvers. So approximately 20% of the entire world, if I send back a big answer in the DNS in v6, silence. You don't get the answer. And if this whole anycast TCP thing doesn't work, 20% of the world can't receive fragmented v6 if I send it to you as end users. It's not very good, is it? I'm like, would you actually make money out of a service that was 20% shit? I'm like, do you really hate your customers that much? I'm like, we said 6-4 was bad when it had a 20% loss rate, but this is okay, we'll just ignore it. It's not okay. So why aren't you fixing it? Because it's not okay. Why don't you think this is a problem, you folk running dual stack networks? Because v4. Why should I spend my time today fixing a problem that users aren't complaining about because they don't encounter it because v4? So in a dual stack environment, there's always the option to go to v4. Happy eyeballs, the DNS, they all do it. There's no incentive to fix the v6 problem because, quite frankly, it's not a problem. I've got problems I need to fix today. So you're not going to fix this until it's too late. That's economics. Go and ask Mr. Kojit, he's good on that. There's no incentive for you to actually do the engineering and incur the cost until you really need to. When you really need to, you figure out you should have done it the day before. Oops. So the fact that it's unreliable means you're not going to fix it. Damn. So what happens when there's no v4? Well, somehow we have to avoid fragmentation because you're not going to fix it. And I've got this real issue because you hate ICMP and you hate fragmentation headers. You are really boxing me in here, you guys. You don't understand the nightmare you're creating. So you think interfaces have MTUs. No. Interfaces plus transport protocols need to have their own MTU setting. So if you're running TCP, go low. If you're running UDP, but not quick, go high. But if you're running quick, go low. Because you're trying to sort of avoid fragmentation is bad, packets that generate ICMP, PTBs are bad. Oh my God, these two things, the walls are coming in closer. I've got to kind of adjust my behavior to minimize the problem. So we think TCP can work. We think you guys can actually make that happen. That's okay. We think UDP can work as long as you don't fragment. Now, what did I just say? I can't fragment UDP? Well, I can't do DNSSEC. That's okay, who needs security in the DNS, you know? CAs are really reliable. They don't normally, certify example.com unless they happen to be semantic. So it's okay. It's okay. The system we have works just fine and I don't need DNSSEC. Christ. You really, really need DNSSEC and we can't do it on v6 the way it currently sits. This is a problem. Because, we're mostly there with v6. Things that mostly work well, but, I can't make secure name services work on v6 only. And if you want secure name services, and I do, I've got to do something. Now, I could get you guys to fix all these packet drops in v6. No. The reason why you drop the packet is not because the equipment's cheap. It's because you've created networks that are session sensitive because you're splaying traffic and you don't want to unorder the packets. You need visibility into TCP and UDP sessions. You want that transport protocol to be at a known place in the packet because that's the way your firmware works and that's fast firmware. If I make it a hunt and seek option, which is what I'm asking for here, I'm also asking for the pig to fly because you're never going to fix it. Your vendors are never going to fix it because you can't. You haven't got the speed of silicon to match the fiber speed unless you drop those pesky packets that hide their transport session. So, you're not going to do that, are you? You mean to say, no, Jeff, we're not. Plan B, alter the protocol. Well, we've been with the old version for 30 years. You haven't deployed it. We can still change it. Yeah, right, I'm like, if the last one was infeasible, this one is kind of, I've really got a problem here because we can't alter the way it behaves. It's just too far down the track. Not many options left. And this one I kind of like. It's DNS. The reason why this thing scaled so well, it was all based on stateless packets. The whole reason why the DNS is free is because it's really cheap. And the whole reason why it's really cheap is that UDP scales like crazy. We can even absorb, not quite terabit, we found that last October, terabit's a bit much, but beyond that, underneath that, we can absorb most of these packet storms in the DNS. We're there, as long as it's on UDP. But if we try and move DNS off TCP, a nightmare has just entered the room because we don't understand how to do this cheaply. So close, aren't we? So close. And fragmentation, the thing that made v4 just take over from DECnet, AppleTalk and anything else, is now turned on us and gone, you can't do this anymore. So for TCP, I'm kind of there. DNSSEC, security in the DNS. Are you prepared to walk away from that? For the sake of v6, are you really prepared to walk away from? As a consumer, I'm not. I really want this to happen, but I don't understand. I don't understand where we go from here. So there is a problem, and it's kind of, I hope, your problem as much as it is mine. So we did a lot of work on this. A lot of people were involved in it. Google has supported our efforts to conduct this measurement. I'm not sure they appreciated me naming the fact that their public DNS resolver doesn't do fragmented v6, but you know, that's life. ICANN have provided support for us too, because we got worried about big packets with the key rollover. You should too. We use ISC server at PAX, and Ray Bellis wrote some brilliant code. So thanks to all of those. You're lucky. I didn't name and shame those networks that have huge numbers of extension header dropping clients. You know who you are, Comcast. Thank you.
Any questions or comments, folks? We have a few minutes. Just want to come to the mics.
Michael Sinatra, ESNet. That was really good, Jeff. Thank you. Just a quick observation. In this particular wireless network, if you try to get a response from my vanity domain for the DNS signed DNS key query, it comes back at 1736 bytes, which means it needs to be fragmented. If you do it over v6, about 67% of the time, the fragmented packet, the second fragment comes before the first. They're consistently out of order.
We're just professionals. We do our job so well.
And my Mac and Dig don't like that, so they don't accept that response. So that's just, it's another. I think that goes back to the hashing of the load balancing across ECMP, that it's consistently getting wrong because the routers can't hash properly as that being part of the flow. It's just an interesting observation.
We got really lazy when we started to think the only way I can make stuff go really fast is to make separate channels. And that was kind of a good engineering reaction, but separate channels meant, oh God, I've got to put the same flow down the same channel. I need to get the transport protocol into that decision. And then v6 says, no, I'm hiding it if you fragment. I've dropped it to a point where the switch doesn't know where it is. Choice A, drop the packet, bad choice. Choice B, scramble the packets. Really bad choice. Yeah, thanks.
Thank you for the great talk, Jeff. Matt Petak from Yahoo here. I'm curious, you seemed to think the notion of going to TCP for DNSSEC was just unthinkable to start with. Is that actually so far out of the realm of possibility, do you think?
Well, it's all a case of loading and scale factors. Because TCP takes state, and I've got to reserve memory for the entire lifetime of the session. In its current format, ask a question. If we translate that naively, open a TCP session, ask a question, close a TCP session, the load factor goes up by a minimum of a factor of 10. If I want the same capacity in my DNS resolution system, factor of 10, this starts to become a nightmare in terms of cost, unless you're prepared to bump in a whole lot of money. But it's a free service. No one pays for this stuff. So where are you going to get the money from, and so on. So partially technical, partially economic, the two combine to the answer from hell. We don't understand how to do this and get away with it.
What do you mean it's a free service? Can you explain this free DNS service you're talking about?
There are a few places where folk will charge me by the query to have my name hosted, but that's rare. Most of the time, it's a different kind of contract. It's sort of, I pay you money fixed rate, no matter how big the query set you host. As the client, I don't pay. I don't send my DNS queries with a check. It's free.
But you are paying, it's just a flat rate. So you're saying that the economics needs to change.
It's a flat rate into a system. If the DNS wants more than its share of the current money go round, it has to put its hand up saying, give me more. And if I'm still paying the same amount, someone else has to say, here DNS, have my money. Now, I don't know what planet you're on, but the planet I'm on doesn't do that kind of thing easily. You know, it just does not give money away.
No, but I think this is an economic problem that we're looking at for this.
Economic and technical, and that's why I'm saying it's never been solved easily.
Okay, fair enough. Thank you.
Don Smith, CenturyLink. Where is extension headers parsed on all routers? Where are the extension headers parsed?
Well, the issue about extension headers is that they're meant to be parsed on routers in case there's a hop-by-hop extension header. That's a problem. Secondly, if you don't understand an extension header and you're a router, is it safe to forward it on? That's a problem. So in all respects, moving fragmentation from fixed into this optional bit of, oh my God, that's a horrible decision, I don't think I'm going to take it, was in retrospect a really, really bad decision.
Thank
And
you.
I suspect the answer is you can't fragment. In V6, you just can't. But the implications is then when I'm heading. So, you know, Steve Deering, where are you? Come back right here, right now, off your yacht. Don't like fragmentation the way it was done. Let's change V6. Plan B, put the rockets on the pig. They still won't fly.
Thank you.
Thank you. Go ahead. Oh, sorry, microphones everywhere. Sort yourselves out.
John O'Brien, University of Pennsylvania. Could you go back to your slide with the diagram of the IPv6 header?
Oh, the 3GPP network diagram. Yeah, right.
No, the header diagram is earlier in the deck.
Oh, the header itself. It seems so simple, yeah.
So in the V6 header, there's a flow field. Why aren't we talking about using the flow field to help alleviate the stress on devices that try to hash based on transport headers?
Sorry. In the IETF, if you've sort of sat in the V6 field long enough, you have to realize there is a rule. And the rule says every new idea you have with V6 has to make a different interpretation of the bits in the flow field. That's mandatory. So it's not as if we don't use it. We have a close to about 500 uses and they're all different. If you're proposing one more use, more power to you, but you've got a lot of competition. That's why we can't use it.
Hi, Alan Durand from ICANN.
Just one moment. We actually are out of time for the talk, so let's have this one question, and then
I'll
we'll
make
wrap
the
up.
answer really fast.
And then
No.
if Tim, if you want to come up for your talk, that'll be great.
Tim's worth listening to. I'm not.
Is DNS over quick an answer to this? And if so, should we put this on the front burner?
If you are prepared to split the DNS apart and have a different protocol between the stub and the resolver and the resolver and the authoritative,
Yes.
if you are prepared to do those massive amounts of savage surgery to the DNS, I believe that there are ways out of this because we have no choice. We have to make this work. And if I was looking at ways to make this work, DNS over quick is a promising way, not necessarily the only way. But I like it. I like it for a whole bunch of reasons, including privacy reasons. So please, whoever's working on that, Christian and the rest of you guys, more power to you. It's good. It's got potential. Thank you.
Thank you.
Sorry, Chris. Sorry about that.
Thank you.
Okay, thanks so much, Jeff.